Right, a spring with K, now, spring with K puts towns placed on the ground and mass placed on the spring. The spring compresses a distance of 3 centimeters. Part 1. Initially, will the reaction force equal the weight? No, because initially it's like this. And then it's going to be like this. And here's our mass, and here's our mass. So at the very beginning there's a reaction force and there's a weight here, and here there's a reaction force and there's a weight. So in part A, of course, this has to be bigger than the reaction force because it's falling, and in part B it's in equilibrium, it's not moving, so it has to be balanced like that. C, how much, let's see, find the mass M. So if we use the last picture, the reaction force is going to be equal to the support provided by the spring, which would be, according to Hooke, Kx. So we get mg equals Kx. So m equals Kx over g, which is 10 times 0.03 over 9.81, which is 0.3 over 9.81, which is 30.58 grams. Okay, next. D. How much work has the mass done to compress the spring? So work was put into the spring to compress it, and the work done was the energy gained by the spring, and that actually came from the potential energy, or the mgh. Now, since we know the m and we know the g and the h, we can work this out. That will be 9 millijoules. Okay. E. If you use the formula work equals force by distance, you get the wrong answer for m. Why? So if you said work is force by distance and force is mg, d, you'll get the wrong answer for the m. Because you'll have here m equals work over gd, and the work came from the potential energy, which we didn't work. Oh no, here we worked out mgh is 9 millijoules. Actually, sorry, did I get the m? Oh no, I didn't work out the m yet for the last part, sorry. I only have the work done. Wait, no, how did I do that? I didn't know the m. Oh, I do know the m. How do I redo? No, doesn't matter. Okay, work is force by distance, which is mgd. So then that means the m is the work over gd, which will be 9.81 times 0.03, and that will be 0.009. That's going to be, no, it's the same. What was I asking here in E? Oh, I shouldn't really use this because I used the m to get that, which I think is what I'm trying to get here, so that was my mistake. Okay, work is force by distance, which is mgd, and that's equal to the work done, which I'll use the other formula, a half kx squared. Okay, so m will be a half kx squared over gd. So that's 5 times 0.03 squared divided by 9.81 divided by 0.03. Yeah, so I get 15.29 as the answer. So in this version here, I said the work done by using this formula is equal to force by distance, which is equal to this. In the last one, what I did was I said the work done was equal to the change in potential energy. So they can't both be right. Which one is the wrong one? Well, I said in the question this one is the wrong one here. And the reason actually has to do with this part is not quite right. This does not quite equal this. And you might have a hint as what went wrong here, because this answer is actually half the right answer. So, if you want to know what went wrong, it all comes back to the picture here. The work that's being done, the reaction force here, this tells us the work that's being done, because this, if we were to look at it from the spring's point of view, it feels this ore pushing into it, which starts off at 0 and then increases to the full weight. So because the force changes, we have to use the average, which is mg over 2. So the mistake here is that this is over 2, which would mean this is over 2, which means this would cancel out. The answer should be twice as big, which matches up with the right answer that I got. So that's what we should do for part S to fix it. We should have used mg over 2 as the force rather than mg. So this is quite difficult, this question, but it was important to see it done this way, because maybe in the exam you do a question thinking you're fine using one particular formula, and then your answer is off by exactly a factor of 2. A common problem that you might not have spotted at first is you should have either used half the force, because perhaps the force is changing from 0 to its full value. So 30.58 is the correct value for the mass, and 9 millijoules is the correct amount of work done to the spring.